Welcome, everybody, to our first panel event here today at the XR Enablement Track. I think this is going to be a blast. My name is Louis Normandin, the COO for Wild Capture, and I'm really excited about today's panel. I'd like to introduce our moderator for today's panel, Alex Goldberg, who is the lead for AR manufacturing technology for Blue, or as you might know them as Blue Origin, over there in Seattle, working at the Seattle HQ. Alex?
All right. Good. Everyone hear me? Okay, it sounds good. It's my third time back here at AWE. It's great to be back in the Bay Area. I live in Seattle, but I lived here for almost 20 years and really miss this place. And it's great to be back with you guys. You're all like my peeps. This is like the one conference I need to be at every year. So, and it's great to see all the same people that I do and I miss. I'm really flattered to have an opportunity to organize a panel discussion. Blue kind of keeps me on a short leash with what we can communicate. So it's a safe place for me to be moderator and then let these guys spill all the goodies on the cool tech that they could talk about that they work at. But I will tell you a little bit about the team at Blue. We're all laser focused on getting mankind off-world. We have a couple of really exciting projects that you could learn more about online, like Orbital Reef and our New Glenn rocket, and some of the developments there, like we just won a big NASA contract. In fact, a team member of mine, Adam, did the renderings for the artwork of that lander that you guys might have saw that was circulated a couple weeks ago when that news broke. I lead AR for manufacturing at our Seattle HQ. And I also lead company-wide initiative that we call Reality Capture, where I create digital twins of our facilities and embed spatial information in those twins. It's not uncommon for me to spend the morning with an astronaut training team building learning material, and then that afternoon be with our engine teams working on a turbopump application. So I'm really all over the place. We're a small team, but we work in every aspect of the company. You know, it's like there's no blueprint or roadmap for the technologies. We're all just learning how to do it together, I feel like, as a community. And we're at a special point where there's a lot of different siloed technologies that we're able to hack together and build really unique special experiences. And I think if you're passionate about spatial computing, working in an enterprise is really the most exciting place now where you'll be able to get a budget to build projects that can deliver and really access hands-free AR in a really exciting way that somebody like me is super stoked on. So thank you all for the technologies that you're working on. And I really feel like we're climbing this mountain together. So thank you all so much. All right, on to our panel.
Hi, I guess I'm in line first. Can y'all hear me? Good, cool. I'm Lauren Marble. I am a specialist solutions architect at AWS, where I've been for the past year and a half in our organization that does spatial computing. There's lots of acronyms, so it just takes a long time to say. My previous life was in industrial augmented reality, starting about 2014. So very, very early on. And I will say y'all are the real nerds at this conference, because who likes industrial XR like this, that they want to come here at a panel talk about it? I don't know, this is new. The first year we went to AWE, I don't think there were any panels like this. And this was definitely not, the highlight. So super excited to be here and to speak with my brilliant colleagues who I've actually worked with in previous lifetimes before. So it's good to get the gang back together and, duke it out. No.
It's fun. It's like a homecoming.
It is of sorts. Yeah, I took a 2-year break out of tech, so I was like, I'm missing something in my career. I wasn't. So I came back. Came back a year and a half later, and I'm super excited to be here. So,
I'm Shelley Peterson. I think my first year here was about 12 years ago, and it has changed so much since then. At that time, I worked for Lockheed Martin, and we were working on using XR technology to build spacecraft. And then more recently, I joined Microsoft as a director to help companies remove the barriers to adoption. And more recently, I've been working with the Barbara Bush Foundation on the advisory board, and here at the AWE on the advisory board, and Global Minded on the advisory board.
So I'm Paul Davies. I'm a technical fellow from Boeing, specifically in the Boeing Research and Technology Group. which is kind of a centralized R&D organization. We support commercial and defense and services, including space and things like that. So my specialty is immersive technologies, and I've been working in the AR space for about 15 years, 16 years maybe. And more recently, for about 8 to 10 years, we're really focused in on manufacturing use cases. So kind of working with a team in Boeing, building a software platform, we call it BARC. I'll probably talk about that a little bit maybe. It's the Boeing augmented reality kit, and it's designed to be used inside the Boeing factories to improve efficiency of operations and build quality and things like that. I'm also the president of the area, which is the Augmented Reality for Enterprise Alliance. And that's a global consortium of 60-ish companies, universities, and other entities, nonprofits and things. And we work together to kind of reduce the barriers to adoption of enterprise augmented reality use cases. So that's the job that doesn't pay, but the job that does pay is Boeing.
So just a side note, way back in the day when I first started coming here, I would go to his sessions to learn what I needed to know about XR in the very early days.
I think I've been coming to, I think it was at the first, maybe not the first AWB, but since then. Yeah.
And I met Shelley in 2018 at VRX,
Yes.
Redwood City, and I was so blown away. She brought Scope AR and hands-free AR on the HoloLens to aerospace, and she's a legend in the field, I just have to say. And then at Blue, to work with her at Microsoft was just a joy. So,
Oh, thank you.
yeah,
We had fun.
we did.
I've been asked to go a little bit deeper into my past, trying to keep it a secret. But I started out at Raytheon Missile Systems as a systems test engineer, which I was kind of my whole career. In some way or another, I had some very weird one-off engineering roles doing nuclear emergency planning. In Japan, yes, during Fukushima, they stood up the response out of our office, and so it's like, that was a neat experience, don't ever want to do it again. But then after that, I went to go back to Newport News Shipbuilding, which is where I kind of found my love for emerging technology. We had a little group there that turned into a big group. So I had to tell people I have career ADHD. I kind of like jump around till I find, found what I'm looking for. And so that's the roadmap that got me here to AWS.
All right, so we're going to kick off the discussion with constraints for adoption. So often in our industry, people like us are experts in the respective field, but we need to bring leadership on board and people at the bottom on board. And who wants to go first on constraints for adoption?
Rock, paper, scissors?
I'll take it. Oh, I've got to set my coffee down if we're going to do that. I'll take this one and we'll do rock, paper, scissors here in a moment. So for all four of us, of course, security is something we have to take into consideration. So we need solutions that we can get into the environment and that meet our IT and security organization's requirements. That was a big one for us at the start, and trying to get the technology in the early stages to validate it, but then also trying to get the approval. It's kind of a chicken and egg thing. So there were some interesting strategies I think probably all of us had to take to get technology in early. There's a list of a bunch. I'll throw that one. I'll toss it to someone else here.
I'll just add on to that one briefly about the security issue. So that's probably my number one barrier to adoption and scaling, because like managing devices and getting proprietary data to like a HoloLens or something is not easy. And so the solution that we've come up with is like, being unable to say natively authenticate to a HoloLens, on the Boeing network, is to like scan a QR code. So you would log on to a computer, because everyone knows how to do that, and then you can generate a QR code, and then you scan the QR code on the HoloLens, and then the HoloLens is now authenticated. Well, it works, but it's not really a great user experience. So you need to find a computer to log on to your HoloLens. So those kind of things, I think we're still in the phase of like really figuring out, how to get past them in a way that users will accept. Because while what we've done, like I said, it works, users sometimes push back on it. And I have another one too. It's more of a technical, another technical kind of barrier, I'll say, and that's the accuracy of alignment, I would say, of at least in the use cases that I'm involved with, virtual content to the real world. In the manufacturing space, it's obviously critical. So we've really limited our use cases to things where either tolerance is very low or really where you're not trying to accurately position something. Say if you've got a part you need to install, there might be some pre-drilled holes. Well, that's fine, right? You can show the part roughly in the right place, but the holes are pre-drilled so you know exactly where it goes. Or wiring, for example, where the whole wire bundle is flexible so the accuracy is not really needed. But things like drilling holes, accurate placement of things, anything like that where you have to guarantee a level of like alignment accuracy, unless we go to the extent of like putting in a lot of infrastructure like measurement systems and external tracking systems, we really can't do it, on mobile devices. So I would say that's been a limiting factor as well.
I want to add to that. One of the things that I discovered is that my engineer works off-site, and often I'm working from home, and I'm not on the manufacturing floor where our engines are that I've been working with pretty heavily lately. And one of the things that we added to an app that I'm working on is the way to turn the CAD model of the engine on to support this thing that we're doing that unfortunately I can't get into detail about. But one of the things we learned regarding alignment is that on the floor, they could turn the CAD model on, and they could reorientate themselves to their physical space by knowing how far off everything is.
Yeah.
And it's kind of a neat trick that was something that we discovered along the way.
We've seen the same thing. Yeah, it really helps.
Yeah.
If all your alignment is off, if you understand how much is off, that's maybe good enough.
Totally.
In some cases, yeah.
It's a huge win there.
If you're in an environment that never changes.
Right.
Yeah.
Unlike the construction of a nuclear-powered aircraft carrier. You walk in one day and you're like, oh, I can set this thing up here. But somebody else is like, oh, an empty compartment. I can put my cabinet here, but my pipe needs to go through it. So,
Yeah.
Another one I remember from your early days out here is you talked about culture.
Yes.
And you probably don't realize it, but I took that one, so what are they talking about with the culture? Everybody should love taking this device out on the shop floor and being able to do work. But I really paid attention to that when you mentioned it. What are they talking about? And studied it and figured out some ways to bring the technology in more softly with the groups, where they could explore it without feeling like they're forced to use it instantly. And that helped quite a bit. I mean, there's a number of different tactics you can take there to have a smoother adoption, but I wouldn't have focused on it if I hadn't heard you talk about it.
And I think the adoption from the culture perspective is double-edged, right? So you have people who are who have been working longer, that might be a little more hesitant, or that's sometimes what people think. But also the people who have been working not as long expect what you can do at work to be the same stuff that you can do at home on your devices with the same ease. And I can just do this, and it's it's so easy. I can send my friends pictures of everything, so I can just send the guy that's doing my QA a picture of this thing, and it's like, yeah, it doesn't really work like that. And then they become disillusioned pretty quickly about what it can do. So there's a lot of nuances, I think, from all from all spectrums around the cultural adoption of these tools and how we build those out so that we use them very smart and efficiently, but also in manners that make it easy for people to kind of shift to this new this paradigm.
I loved working with the seasoned engineers and technicians.
Seasoned.
Yes, they were fantastic. So they're going to give you critical feedback. They're going to tell you what they think. And it works even better if you ask them for it in advance. And you go, hey, I want your input on this. I want to know if it's ready or if it's not ready. And then they're usually kind of on board to experiment with it. They try it on and they'll say, oh, that use case, that's not going to do us any good. Here's where we really need it.
Yeah.
And they know because they've been there. And then if you can find a way to get that to them on the shop floor, then they're engaged because you helped give them a solution that aligns with what they need.
Yeah.
And I even had one technician who moved his retirement date because we were working to get the technology on the shop floor, and he wanted it out there before he left.
Wow, that's so
It was
cool.
fun to see. But
So speaking of becoming disillusioned quickly, the next talking point is the biggest unexpected failure, and I'm going to start this one off. And it might be a surprise to you guys, but a problem lies in how cool the technology is. Because often, like an integration engineer or manufacturing engineer will get their hands on a HoloLens and they're just blown away by AR, and they think that they're like Iron Man, and they even act it out like from the movie, which is kind of funny to watch different people do. And unfortunately, a couple of weeks later, if you're not bringing value with your technology, that coolness factor wears off quickly. So it's deceiving in the beginning to have the coolness factor of the tech we work on and people that are super stoked on it from sci-fi films and whatnot, and then have that wear off. So I don't know if you guys have experienced similar things.
I've never experienced a failure.
Fair enough.
All of mine were expected. No. Tons. So
Just laugh.
I think in this space especially, it is difficult to kind of align or title some of the things you've worked on necessarily as failures, because I think when you're so early on in something, that's what yes, we've come a long way, but we're nowhere near where we need to be to see this vision, not just in industrial AR, XR things. So every failure really is a POC, right? How many of you have made it out of POC purgatory? I won't even say how many are in it. Got a couple, not many. I need to talk to y'all afterwards. But there are definitely some areas where there was a time when we did an experiment or a POC. AR was brand new. We were using iPads to deliver our AR, which I still think is good in a lot of use cases. Fight me. But it was an unexpected failure because we actually proved a lot of ROI on this one particular thing. And then we're like, fantastic, we've proved this ROI, we're gonna use it for all this stuff, and then it was nothing. And then it was like, yeah, we can't manage all these devices, we can't provide the security. And this is at a time when at the shipyard you couldn't even bring like a cell phone in, or we had no Wi-Fi. There was no cloud. So the project did fail because we did prove out the ROI on it, but there was nothing that happened afterwards. There were all these things that, we just figured we'd deal with them afterwards once we proved the ROI. And it's significant. If you intelligently deploy AR, the ROI is incredibly significant.
Yeah.
But there's all the other stuff that you have to do along the way, like the content management and the CMS and the monitoring your equipment and security and all those things that made it literally didn't go anywhere after that. It was like, great, that's neat, I guess.
Failures. There's a bunch of them. I mean, I could go into storytelling mode.
Like you were so sure this thing was going to crush it, and then something surprising that you weren't expecting.
There's a bunch. But one of the fun ones early in my pursuit with AR, I think it was 2011, 2012, we were excited about the technology. We'd been pulled in to brief the 4 executive VPs at Lockheed. So the production VP for space, aeronautics, missiles and fire control, and rotary mission systems. And they'd all gathered and had a very short time to go up and do a demo in front of this group back in the early days. And so we had a device that had a depth sensor, and I pull up the information, and all of the models started doing this across the room, and they were jumping everywhere. They wouldn't stabilize. I have never seen this before.
Right.
What is going on? So I'm thinking, trying to debug real time, what is going on? And then I realized we're in a executive conference room, which normally I was not in at that time, and had glass walls, and everyone had a glass of water. Like, okay, everyone take the glass of water and put it under the table. And guess what? It's stabilized. And I was like, oh man. And I thought it was a huge failure because all of this is happening in front of them. And it's like, how did I not test that? We build spacecraft, we should be testing things. But they kind of liked the thought logic of figuring things out real time, and we had a good laugh. It was fun. That was one of the failures.
Good save.
But lots of failures along the way that we learn from. And I'm not the type, in the space industry, you don't exactly celebrate failures the same way that we all say, whoa, failure. No, we plan to test to failure, and it's a engineered thing. So, but there's some good stories there. We need more time.
Yeah, I have an example, and I probably prefer to use the term learning experience rather than failure.
Yes, thank you.
But, and it actually, so it relates to the talk I gave at AWE. It would have been like, I don't know, 2018-ish, 2017. And I stood up on the stage, and it was like a packed house, and the title was like Boeing Scales Augmented Reality in Manufacturing or something. And it drew like a lot of people. And I was showing pictures of the wiring use case. And it was on one of the commercial programs, the 767. And back then we had such great alignment between all the teams that needed to support this kind of work. IT executives, information security, Boeing research where I am, all the program vice presidents were all on board, and everyone was really pushing in the same direction. And I thought this was going to be a slam dunk. And we did a pilot, and we had over 2,000 hours worth of usage of a HoloLens to install wiring on an aircraft. And we collected a whole bunch of data, and the data looked good, and it showed time savings and quality improvements, that we, really encouraging stuff. And then we weren't able to make that stick, and we weren't able to, and today they don't use the tool. And that was really surprising to me. Again, I don't necessarily see it as a failure, but more of a learning experience. We looked at why, and it was things like, ergonomics of the HoloLens 1 at the time. It was a prototype of our software that had bugs in it at the time. And while we thought we could work through those things with the program, I think we reached a point where, although it was working and the data looked good, we kind of tipped over the kind of the peak, and the user community, the electricians, started to just not use it more and more because there might be a problem with a bug that needs to be fixed, or they couldn't get the particular drawing they wanted to review. So yeah, that would be my number one. And I still get asked to this day. I mean, we even had the CEO of Boeing come to see a demo of what we were doing because it was getting such good attention and such good reputation. And even today, I still get asked by certain executives, whatever happened to that? Why didn't we do that? Why can't we do that? Are we fixing the problems why we weren't able to do that? And I think we are, and we have, and we actually have another pretty big opportunity to try again this year.
Nice.
So I can't talk too much about that, but I'm pretty excited about it.
Very cool, good
I
one.
had one more failure one that was kind of a fun one.
Let's hear it.
We had a group that had a panel, a big spacecraft panel that was kind of curved. And we were flying down to a facility, a NASA facility, to work on this panel. And we expected it to be upright, curved, big panel, kind of like taking this screen and curving it, only maybe twice as tall. And as we were flying down there, they said, oh, by the way, it's not going to be standing upright. It's going to be curved like this.
Yep, been there.
And we went, okay, we can handle that. We do a quick fix, and we're good. And then we get there, and we're overlaying the content on the structure, and it aligns beautifully. And then they start to work. Hold my beer, my coffee. And they get up on top of this thing. They're standing on top of it. Well, guess what happens? It goes from this to this. And so now we're trying to overlay content on a flex structure that is no longer in the geometry that it was in when people were not standing on it. And so we had to do all kinds of creative things on the fly to make it work, which I guess wasn't exactly a failure, but it was one of those things where there were a lot of unexpected moments that we had to recover from quickly.
Those are fun ones.
yeah.
Yeah, there's been many times where I've been working on projects where the component was orientated vertically, and then one day out of 3 weeks when we need to go do a demo or show somebody something, it's in a horizontal, and nobody mentioned at the start of the project that they do reorientate it to do this one thing on this one day. And then I build buttons into my apps to flip things 90 degrees for this, to handle those situations. That's what we do. We roll the punches.
Yep, we go with it.
And if you want to just words of wisdom to take home with you is if you want to test a POC out, really test it out, do a demo. You will find every bug you did not expect to find in that moment. And if you really want to drive a point home, do it in front of middle schoolers, because they will tell you, and they will do everything they can to break a piece of equipment, to push all the buttons in manners you didn't expect, and that'll save you some time down the road.
Murphy's
good
your
plan.
best tester.
Murphy is your best tester.
So the opposite of biggest unexpected failure is the biggest unexpected win. I got a fun one for you guys. So I can't mention, I'm not permitted to mention products that we use, but I'll say that it's a hands-free AR headset that's see-through and a predominant one. So it's also notorious for a limited FOV. But, you know, a limited FOV could work to your advantage. And when you're inspecting, when you're assembling something, and that in AR it is displayed how this part should be, you could ride the edge of the FOV and see reality, and then the as-designed CAD model that you imported into your AR scene. And I call that riding the edge of the FOV. So a small FOV could actually be a big win in certain circumstances. Other unexpected big wins for you guys?
I don't think Paul's gone first yet.
Yeah, I have a couple of examples. I mean, I don't really say it's like one particular point in time, but or maybe it kind of is. So in the early days, we were trying to deploy these AR experiences, and we had no like back end to the system. So it was all manually converting models and storing them on a tablet or a HoloLens or something. And we all knew that wasn't scalable, right? So for many reasons. So then maybe it was about finding the right people to work with. But at one point, probably around the same time we were doing the tanker work, found a couple of software engineers at Boeing who really resonated with the need to scale these things and do things right. And we put a lot of effort into what we call the BARC backend, what the BARC services. And over the last few years, that's why I say it's maybe not one point in time, but over the last few years, we've really built on that. And now we have BARC as the platform connected to, off the top of my head, I don't know, 8 to 10 manufacturing systems, PLM systems, data repositories, and a fully automated translation pipeline that's enabled, that you can go view any one of thousands of models now. And I never thought that would be achievable anytime soon. And maybe it was about finding the right people to work with, because I wouldn't have been able to do that all myself, but maybe I found the right people. But that, over the last few years, it was really, in my mind, kind of resonated as a big success that we've been able to drive.
Let's see, story time. So way back in the early days, we had run an activity on the shop floor for the first time. And we were saving 50% touch labor on, it was a torque application. We were so excited about it. And I was talking to one of our NASA site engineers, and he said, that's a good one. He said, we'll definitely save on that one, but if you could just tell us where to place these objects on spacecraft panels, like fasteners and strain gauges and heaters and thermistors and that kind of thing, we could save a ton. So this should be possible. We should be able to hit the tolerance levels. And within a day or two, we built a scenario and went down and they ran it. And we found that we could reduce 93% touch labor. So 8 hours worth of work in 45 minutes. Essentially saving about $40 a fastener. The company was purchasing 2 million fasteners per year. This is fantastic ROI. This should pay for whatever we need to purchase in order to get this going. We went down, I realized we couldn't exactly go to leadership with that yet because it was just a number that was too crazy to believe. So we went to Denver and did strain gauges, and we went down to Kennedy Space Center. We're inside the Artemis spacecraft, and we're placing these fasteners inside the spacecraft. And the site manager shows up, and I think we had to place like 600 of them. Or normally it would take them 6 or 8 shifts to do this. So the manager sticks his head in the spacecraft. Where are you guys at? We have about 200 done. So it's only been an hour and a half. Yes. He goes, okay. He leaves. He comes back with the director. The director sticks his head in and says, where are you guys at? Well, we have about 300 done. That's about half of them. It's only been a couple hours. He leaves and comes back with the VP. And same reaction. And then it got really busy. But then we had 3 different scenarios, 3 different groups of people, 3 different sites, all with 90-something% touch labor reductions. And then that was the use case that took off. And it was a very simple one. It's not having an avatar next to you guiding you to do things. It doesn't have some of the flashiness of some of the use cases that are out there. It's very simple. But it allowed us to communicate in value, the value of the technology, which allowed us to get it going and get a foothold and move forward.
Was that with Scope?
Yes.
Yeah.
Yeah, that's WorkLink.
Dang, telling all our
ins-
secrets out here.
Installing bolts, or also known as fasteners, most of the time those words are used interchangeably as a big part of our manufacturing processes. And AR could be a big win for expediting that process.
Yeah.
Yep,
It's impactful.
totally.
I think the most unexpected win I actually had was pretty recently. It was with a company that I did not, so we're here because we all like industrial XR, and that's like our passion, and it is my passion, and I love it. But I work for AWS now. I don't work for the shipyard anymore, and so I've had to broaden my horizons and take on new things. And so I recently worked with a large bank that wanted to build out a metaverse platform. And if you are real deep in this industry, that term metaverse just does something to you that's not great. But that's what they wanted. But that's what they wanted to build out. And actually, they had it pretty well defined and all these things. And the reason I'm bringing it up in here is because we ultimately went two paths with this customer. And one path is like, yeah, we'll help you build out this metaverse thing that you want to do. But the other one they realized is we can actually use a tool that we created at AWS called Visual Asset Management System. And we want that to store all of our data to feed all of our things, whether it's the metaverse or our website, anything that has to do with communicating or interacting or collaborating with anybody, we want to be able to use this. And VAMS was absolutely not created for banks to create their websites or anything like that. It was birthed from engineers who needed, a place and a way to store their digital data. All these assets need a lot of love and a little bit of work, lots of optimization, and typical storage solutions don't really offer that. So a colleague of mine who's here, he's running around somewhere, created VAMS, what we call, and the bank adopted it, and it was really our first SOW for somebody to actually engage with us to put it into production. And I called him, I was like, is this really happening? Did they really just, because we've been, again, in POC purgatory, we've done lots of prototypes. We've done lots of things with the companies that I love to work with the manufacturers and stuff, and things get, sticky, and things happen, and people leave, and your champion leaves, and you got to find somebody else. And here this bank is, and they're like, oh yeah, we'll give this a go for, not insignificant amount of money. And I was like, okay, let's do it. And it, the use cases might be wildly different, but the overlap of technology, if they can prove this out, if they do, when they do adopt this into their actual workflows and their everyday work, that will benefit the industries that I do enjoy working with. Not that if they're watching, I love you guys. I don't not like working with you guys. It was just very, very unexpected.
So you're a vendor now. You're at AWS that companies like
The dark side.
Boeing and Blue will rely on. And VAMS is a pretty amazing product. I'll personally go on the record. I can't speak for Blue and say that, but I know David and the crew and how hard you guys worked on that technology. What do you guys think is a key to a successful vendor relationship? Maybe Shelley has something to say on that.
I look out across, I go, tech partner, tech partner, tech partner, tech partner. Sorry, everybody, these are my favorite people, tech partners. They enable us in a significant way. I'm actually talking about it on the main stage at 535. You want to have a solid relationship with your tech partners. They can be incredibly helpful with helping to figure out the challenge. So for a while, I was in the mode of, okay, we have to provide very specific requirements on how we're going to solve a challenge. Then I realized it works a whole lot better if you tell them what the challenges are. Hey, can you help me figure out what we need to do about this? And they come back with ideas that we never would have come up with that are fantastic. And ways to do things that are pretty innovative and also allow you to build on that innovation in creative ways. So I think collaboration is key for that. Having a roadmap that, it also helps if you have tech partners who share with you what their upcoming roadmap looks like so that you can work with capabilities and deploy those at times that make sense both for your company and for the tech partners. So that collaboration is key, I think, and I don't know how we would have done what we did without our tech partners' involvement. It was very impactful.
Transparency and openness and
Yes.
providing a little over the radar.
Working to a schedule, staying within schedule, on budget to provide value, and having them a part of that process, I think is key.
I'll say from the vendor perspective, what helps us help you is aligning or putting in a lot of time to align champions across, or align levels of leadership that can actually see a POC through, that can help scale it up afterwards, because we have a ton of good ideas. We have big ideas, we have great ideas, we put all this work into it, and then somebody's never heard of it. Or again, like I mentioned earlier, somebody leaves, and so there isn't this kind of network of champions to adopt technology. It can be difficult, We have an amazing go-to-market team that we work with that kind of seek out those relationships, which is really lovely. But I'd love to even make their jobs easier to keep those wheels moving, to keep those ideas going and seeing them out. So that's on y'all. I'm just kidding.
So this clock in front of me, it's counting down just past 2 minutes. So I guess we have less than 2 minutes left, and then there's a Q&A.
Yeah, that's a little off. Go ahead and take the time you need, and then we'll push into Q&A.
Right on, thank you. We have a couple more exciting things. So I'm going to shift to most promising breakthrough technology that you guys are all super stoked on. Maybe besides AI, or you could expand on AI?
I'm not going to touch AI. For me, it would be it's not a single point in time, it's more of an evolution over the last couple of years, but the mapping and traffic tracking technologies, or SLAM technologies, that's really enabled inside out, onboard localization of devices. So I've been working in this space for long enough where it's like, we used to try to do tablets, and like I think I mentioned, we would install expensive motion capture systems to track the tablet, and all that worked great. But then, I remember the first time I went to Microsoft and the HoloLens 1 was announced, and we saw a demo, and I didn't believe it. I didn't believe it was real. I was like, where are the sensors in the room? Like, how are you guys doing this? And then it dawned on me that it was real. And then since then, it's really exploded, like Magic Leap and all the other companies are building their own, SLAM localization. So that's been a real game changer, I think. And it's not really maybe not a forward-looking like breakthrough technology that's coming, but I think it will be, because as accuracy gets better, that'll enable more use cases that we can deploy and things like that. So
There's so many options: area targets, model targets, object anchors.
yeah,
ASA, Azure Spatial Anchors.
exactly. Yeah.
We have so much at our fingertips to leverage now. It is so exciting.
And it's all happened so quickly, I would say. The last several years is really, well, a few years, I guess. Yeah.
Yep. It was just QR codes in the beginning.
Yeah. Right.
And now the QR still has a purpose.
Yep.
You guys?
I think this was on the bottom of my list of questions I wanted. No, I'm just kidding.
I know what was on the bottom of yours, actually.
It's not difficult to get excited about like a breakthrough technology. What I want is like the technologies we have to fully mature. Like that's what I'm waiting for. Like AR is here, VR is here. We can put them all together. We can do amazing things with them. Why is it so hard to see that out, for companies to adopt them in this space, right? I mean, we all know what those constraints are. We talked about them a little bit. So I think the breakthrough to me is going to be when we can just easily use those, when you don't need the tech expert. You can have the training team can create training, right? You won't need a whole handful of developers. You don't need a whole bunch of different people. You won't need, all the different things. But the way that these things interact to be either standardized or just better understood, that's what I want. Like, I'm here for all the cool stuff. Like, I want the next generation of heads-up displays without tethers, preferably. But those are all fun. I love Gen AI. I love all the different things that are out there to help us get there. But they're cool. They're shiny. I want the things that we have now to fully mature. That's what I want.
I totally agree with that. Yeah.
100%.
Yeah.
Hundo?
And also no tethers in a complex manufacturing environment.
Yeah.
environmental health and safety groups do not want you catching a tether from the back of your headset on something. So that's often a hard stop, as is pass-through AR.
You know what happens if you drop something on a spacecraft? It's not good.
Yeah.
You have to go into test mode, and they have to decide if they're going to launch as is or if they rebuild something. So you don't want anything that's going to fall off of you. Everything that you have, even the tools that you have, are tethered somehow.
Yeah, I've heard stories of screwdrivers falling off of a ladder that fell 10 feet and made just the smallest dent. It was $500,000 worth of damage.
One of the
So it's our
reasons
environment that we work in.
One of the reasons we were able to get wearable devices into the spacecraft shop floor more easily is because a handheld had been dropped onto a spacecraft component. And they went, well, if you're wearing it on your face, it's probably not going to fall off. So it was a little bit easier to do that. It was a solution that they were, that they approved of. But in terms of future technologies, I think cloud rendering, I've seen some amazing things from cloud rendering, remote rendering, that could be key to opening up all kinds of new capabilities. I think that's one. I think that the way that we transmit data, did you know that you can take these types of lights and modulate them and stream data in place of Wi-Fi or Bluetooth? So you can also do device to device. There's some really interesting things you can start to do. If you start to communicate and triangulate based off of these, like instead of star calibration, you're using lights in the room, and then say a mesh network of other transmitting things around the room, how does that change how we work with devices, what data we can process into what we're seeing and interacting with?
Yeah, I'm very excited by that. I think the nickname is Light-Fi.
Li-Fi is
Li-Fi?
modulated light,
Yeah.
and that's a fun one. If you're not familiar with it, take a look at it. It's you're streaming data over light. You can stream much faster because it is light. In secure environments, you don't have to have a skiff to contain the data. It's contained by the walls because it's light. So it's a game changer for many areas.
And as you were mentioning, edge offloading compute and pushing that to headsets that have limited processing power locally is a huge win for the kind of work we do. And being able to support that with interactive experiences as opposed to passive ones, and some of the breakthroughs that are coming are all very exciting. Lauren, did you have anything on this boring topic?
I fell asleep while you were talking about it. No, I'm just kidding. No, I said it. I started. I kicked it off.
Okay.
Yeah.
I think we're ready for the Q&A session. I totally spaced that.
Are you good? I'm very forgettable.
Well, we have a microphone here. If anybody has any questions, go ahead and raise your hand.
Question right here.
No microphone
All right.
needed. Okay.
He's got it.
Hey, Daniels, and I appreciate this panel of seasoned professionals. So I've been in the AR industry since the late 90s, and I've had a long career developing all sorts of high-end, high-fidelity training simulators, flight simulators, tank simulators. I'm a former Lockheed systems engineer, worked there for 15 plus years as well. So Lauren, you kicked off something that I was going to ask the question. So you talked about visual asset management from AWS, and you mentioned VANs. And then Paul and Alex, you two talked about CAD models. So I want to ask the question about managing assets from the CAD side all the way through to the AR version of it, and maintaining that the concurrency of that model. If you have any,
That is huge.
You talked about BART. I'm not sure
Yeah.
BART
That is such a, we could spend an hour talking on optimization of CAD to the headset. We touched on edge computing and keeping CAD closer to what was originally designed that might be living in the PLM system and not having to decimate that model to pushing it. There's so much there and so many different novel optimization techniques. Gosh, there's a lot to discuss besides it being a point of contention of a lot of times what you're left with, depending on the route you take to publish your AR model, is something that will have the topography of what that original model was supposed to have, but it often takes a hit. What do you guys feel about all that?
Well, I was going to say it's a great question, and it's like probably the number one topic that comes up when you try to do the AR in manufacturing is, do you have authority of the data you're looking at? Is it real? Is it the latest? So I can just give you a few examples. For us, in our use cases, the process varies because all of our programs do things a little differently. They all use different systems. So there's one example I can think of where any engineering change gets pushed automatically to a lightweight geometry, and that is all stored in a parallel data store. So we can go grab any of that at any time and display it. So that's always up to date. Most of the time, the user needs to trigger a process to go get and translate the data. So it's not a kind of a push from the CAD, it's more of a pull from the user. So if you want to view a particular drawing, you got to go to it's a BARC website, and you enter a drawing number, that will start the process to go retrieve, say, CATIA files or whatever it might be, JT files, translate them through some service, and then put them in some other storage facility where we can go get them. And when all that's done, the user gets a notification saying, okay, your AR experience is now ready. And then we time that experience out after it's configurable. It could be 5 minutes, could be 5 days. But if you try and view it after that time, it won't let you, and you've got to go re-pull the engineering again. So I think that maybe was what you were asking about.
Yeah, talking about sort of the process that you put in place to deal with that. Because, when we're managing hundreds thousands of models,
Yep.
It's typically a pull from the user end as opposed to the engineering pushing these new models down. So I was wondering if y'all...
VAMs?
That is 100% the use case or the process that VAMs is trying to address. So VAMs is open sourced. It's on GitHub right now. If you go to the AWE labs, I'm sure some of our talks, we had like 5 of them that referenced it. But that is 100%. So it doesn't, we're not going to replace a PLM system. That's not what its intent is. But its intent is once you're done, once you get what you need, you put it in a centralized place. And so that every time you modify that model, it doesn't destroy the original, but you have the version that you need, and everybody can go and get it. It's easily distributable. You can embed your processes and workflows that you need to convert and optimize those models. But that is 100% where VAMs came from. It's this, we have 20 different systems, and everybody's saving them in a folder, and you don't know where they are, and it's like, okay, well, if we can get people to put them into one centralized repository, then let's start solving some of those problems, and that's 100%.
It sounds like old school Cedrus, but it's a common repository, long time ago.
Yeah.
Oh.
I'm just going to
Somebody's
sit back
done it?
and drink my coffee and hand my microphone to the tech partners, and now you see why I like my tech partners. No, there's a number of ways to solve
You have
it
another,
depending on the challenge, but it's a long discussion depending on what route you take.
Yeah, it is route dependent. Offloading compute cuts a lot of that out of the equation. Once you deploy an app, the model is stale already. The annotation sets that might be getting updated in the PLM are now not what's deployed to the headset. So you need to have the foresight on deploying what's going to be stable for the team that you're working with, and all those things need to be taken into consideration. It's a great question, though.
Yeah.
Yeah. That woman?
In the microphone?
Is this thing on? Yes. What advice do you all have for convincing internal leaders to invest in your ideas for optimization?
Value, value, value. Show them the value. Show them what they can get out of it. Enlist your groups and figure out how to communicate to them in terms of the value that you're going to bring. And if you can get that point across to them, if you can figure out what their challenges are and figure out more effective ways to solve them, it usually breaks funding loose from some angle more easily. Sometimes it's hard to find funding at the start. There's a chicken and the egg. You need to validate the technology to get the resources, but you need resources to validate the technology. So you have to break through that. And one way to do it is through showing value.
Persistence.
Yes.
Somebody's going to tell you no. Then somebody else is going to tell you no. So don't, forget what your day job is. But if you have an idea and you're passionate about it, eventually somebody's going to listen. They have to. We're kind of at a weird period right now where there's so much technology and some people, kind of a little disillusioned with. We're kind of wading through the trough of disillusionment, maybe coming up a little bit on the other side of that. So you know, whereas before it'd been like, oh, new shiny object. They'd be like, okay, cool, new shiny object, let's do this. Now it's kind of like, I've seen like 20 new shiny objects and whatever. But if you really like, you know, if you feel very passionately and you think that this, you know, something is going to help a process or an end-line user, an end-line worker, like the people that are actually building, the people that are constructing, the people who are QAing, if you can prove that you can make their job better, faster, easier, somebody's going to listen to you. But lots of people will also tell you no, so.
You know what no means? Find another way. There's an NO in there. You just find another way.
And I don't have a whole lot to add. Just, I mean, to steal a quote from a colleague of mine, in God we trust, all others bring data. So if you can spend some time in collecting some data, I mean, you really can't argue with it. So data, in my mind, in my use cases, would be like build time and build quality. So if you can have data, you know, it's irrefutable, that improves those things, it's not that hard to get buy-in from people.
Yeah, the 3 value points that I try to home in on are reduction in headcount, reduction in NCs, non-conforming parts, which are problems that happen, errors, and reaching the project completion time quicker.
Yep.
So, yeah. All right.
Accelerate. The best way to.
Time for one more?
Go one more.
Okay. While you're doing that, I'll say skip the proof of concept process. You don't want to get stuck in POC purgatory. Skip it. And there's some interesting ways you can do that.
So since you guys talked quite a bit about the CAD, so how about the off-the-shelf solutions that traditional CAD vendors like PTC and Dassault Systems are offering, and where do you see the kind of the gaps in there where startups could really pick up and maybe help, right, in building this ecosystem?
I know for us, for AWS, one of the things we really talk about a lot is our partner ecosystem. So it's not an either or for us. It's not, you know, AWS builds out a lot of services, especially when, you know, mostly when customers say, we have enough customers say, we need this, okay, we'll build it. Not even all of our services solve all those problems. And so we're actually very proud of the ecosystem that's not just from, you know, big GSIs, but also from a lot of startups and a lot of smaller mid-sized companies too. So there's room for everybody. I mean, this is a vast field. So, but that's kind of one of the things when I say like we have these things now, I want to see them mature. There are still gaps in, you know, whoever's solution, and so I want us all to collectively figure out the right framework so that, okay, do we keep it, you know, we'll have this specialized thing and this specialized thing, but this is how we bring it together. I don't know what the full right answer is. That's why my job is a lot of fun, because we spend a lot of time trying to figure that out. But it's not necessarily for us like a competition. It's like, come play in our field together with us and help us build that out.
I mean, the tech partners that we were most successful with were the ones who would work with us to see what we needed. They would shape the technology to what we needed. They would inform us of their roadmap and the schedule that they were working to, and it helps a lot when they can meet that schedule or communicate to us early if it needs to shift, especially with spacecraft, because you may be building something once and waiting several years and then doing that activity again. So that communication is key. We work a lot in the early stages on waivers. If there's a way to get ATOs, authority to operate, that's huge. It's a long process to get there, or a Suite B authorization, something along that line, where instead of getting approvals with each program, there's something that says it's been authorized. That's helpful. It's not required, but it's helpful.
Yeah, we're going through that process now actually with some vendors or tech partners in basically, you know, shaping requirements and helping them understand what we need. But I've noted, you know, in general, I find that I would say AR vendor space have trouble understanding the complexity and the true environment that we're trying to use the technology in. So it's one of the things we do with the area is try to bring the vendors closer to the enterprises so that we can try to better understand each other's space that we work in. So that's been a problem for us.
All right.
All right.
A warm round of applause for our panel today. Our moderator has been Alex Goldberg, And the panel guests are Lauren Marble, Shelley Peterson, and Paul Davies. Thank you, everyone.
Thank you, guys.
Hey,
Great
thank you.
job. Yeah.